Okay, so starting in about 4th grade, you all learned that there are multiple ways to represent a number. Yes? So, for example, you learned that a decimal can be written as a fraction, and it can also be written as a percent. So if I have 25 cents, how else can I write that and have the exact same value? 1/4. And as a percent? 25%. These are all the exact same number. Y'all understand that? This is basically, I have a quarter in my pocket. This is 1 out of 4 quarters. And this is 25% of a dollar. They all have the same value. It's just different names for the number. For example, my name is what to you guys? Miss Castro. Is that what my child calls me? No, what's my kid call me? Mom. Right? My niece calls me aunt or auntie, whatever, right? Everybody calls me something different, but do I change who I am when y'all call me something different? No, I'm still the same person. This number is the exact same as these, just written in a different form, okay? Okay, so what we're going to learn today is that there is another way to write numbers. So we're going to take a number, and this way is called scientific notation. We are not going to change the value. Can you talk her, please? We are not going to change the value of the number, just like the value is the same up there. So we can take 25 cents and now make it into what is called scientific notation, and it would be written like this. Okay? This is scientific notation. So, what is scientific notation? Why in the world would we use it? Scientific notation was created by scientists. Scientists study very, 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 very big numbers and very, very, very little numbers. So think about the weight of a feather. Is that a lot or like super, super little? Super, super little. And then think about the distance from the Earth to the moon. It's super, super big. So scientists got tired of writing numbers that had all these zeros on them. So for example, like the weight of a feather might be something crazy looking like this. And I'm totally making this up. It might be like something like this. And scientists are like, whoa, that's too much to write. Is there a way that I could write this number and it have the same value without having to write all those zeros? And they came up with what is called scientific notation. So scientific notation is just another way to write a number that's really, really big or really, really little. It is based on powers of 10. So that's why you saw, what did I write? 2.5 times 10. It's always going to be times 10 every single time because it's based off of powers of 10. All right. Standard notation is a normal way of writing a number. So this is the normal way. Where scientific notation is based off powers of 10. So if it says put this number back in standard, standard is just like decimal notation. So which of these up here is standard? This one, this one, this one, or this one? That's standard. That's fraction, that's percent, that's scientific. Okay? All right, so why is it based off of powers of 10? In elementary, your teacher taught you a trick, but she kind of fibbed to you. She said, hey, when you multiply by 10, just add a... Right, she said just add a 0, which only worked in elementary school. Because, for example, everybody look, if I want to multiply 5 times 10, I can just add a 0 and it becomes 50. But if I want to multiply 0.25 times 10, adding a 0 wouldn't do anything to it. So multiplying by 10 is actually moving the decimal place one place to the right. That's what your teacher should have told you in elementary school, but you didn't understand it, so they didn't tell you the whole story. So what does multiplying by 10 actually do? Moves the decimal one place to the right, okay? So multiplying by powers of 10 moves the decimal one place to the right. All right, so that's the foundation you need to understand scientific notation. If you don't understand it, your calculator is going to do it for you anyways. Everybody's head should be off their desk, paying attention. All right, this is what scientific notation looks like. This number right here is your base number, and it has to only have one digit before the decimal, and it can't be 0. So this number right here can only have one digit before the decimal, and it can be 0. That's just the rule they made up, okay? Then you're going to always multiply by 10, because that's what it's based off of, powers of 10. And then this number right here is the exponent. It tells you how many places to move the decimal. And I promise, guys, this is super easy. It's going to be confusing at first, and then you're going to be like, oh my gosh, this is like the easiest thing ever. So, what did I say happens when you multiply by a power of 10? It moves the decimal? But what if I want to move it 5 times? Then I put an exponent of 5. Because that would be multiplying by 10 5 times. And every time I multiply by 10, I move the decimal 1 time. Does that make sense? If I want to move it 10 times, what's my exponent going to be? 10. If I want to move it 20 times, my exponent's going to be 20. So where did this negative exponent come from? Because if you put a negative exponent, instead of moving the decimal to the right, you move it to the left. So everybody look, I took this number and put it in scientific notation, which looks like this. How could I make it look back to look like this? I would move this decimal one place to the left. Do you see why I put a negative 1? It's super, super easy. So if you need to move it that way, it gets a negative exponent. If you need to move it that way, it gets a positive exponent. It's that simple. Okay? And again, your calculator is going to do all this for you, but you do need to understand why. All right. So right here, it says to convert from normal, which is called standard, to scientific. So here's a normal number. Do y'all agree? Yes or no? To go from here to scientific, if you want to do it by hand, all you would do is take this number and put the decimal after the first digit. So it would be 5.37, leave off the zeros. Now, if there's zeros like wedged in here, you have to keep them. Okay? So do you see where they got the 5.37 from? Then you always say times 10. And then you say, how many times did I move the decimal? Well, from here to here, I moved it 1, 2, 3, 4 times. So why did I get that exponent? Because that's how many places you would move the decimal. All right, look at this one. Is this a really tiny number? So what kind of exponent is going to be? It's going to be negative. All right, so we move the decimal from here to here, because it's going to get the 9 first, because you will say, what's the first number to the left, not zeros. What's the first number? 9. So it's going to be 9.8. That's where that came from. And then we're going to move the decimal from here to here. So 1, 2, 3, 4, 5, 6. Since it's going to go that way, it gets a negative. Easy? Now guess what? Your calculator is going to do this for you. So I'm going to teach you how to do that, and you're going to write it right here. So to do it in your calculator, to go from standard to scientific, you're going to go to mode SCI. And it's literally going to do it for you. So everybody turn your calculator on, find the mode button, which is here. Did y'all find it? Hit mode, Do you see normal? And then right next to it, it says SCI. Right now, you're in normal mode. But we want to go to SCI, so arrow over to it. And then you have to hit enter. And you'll see normal is no longer highlighted, but SCI is. Yes? All right, go to second mode to quit. And I want you to type in this number. Do not put a comma. Commas do not go in your calculator, but decimals do. So type in 53,700. Hit enter. Did they give you the answer? The only thing the calculator is not going to tell you is times 10. You have to know to put that. So you would write 5.37 times 10 with an exponent of, is that what we have? 5.37 times 10 with an exponent of 4. Yes. So is the calculator going to do all the work? So I want you to write down that it's going to give you 5.37 E4. But you are not going to write the what? The E. What are you going to write instead? Times 10. Okay, put this one in right here. Do you have to put decimals in? Yes. So you put decimal, and then I have to count because I can't see that. 1, 2, 3, 4, 5 zeros. So 1, 2, 3, 4, 5, then 9, 8. Hit enter. How would I write this? 9.8? I don't hear anybody.
9.8
times 10 with an exponent of -6. What do y'all think? All right, so I want y'all to go convert these to scientific. Do we write the E? No, we write it as an exponent. So let's go do this one. Do I put in commas? No. So I'm going to type in 61,300,000. And all I have to hit is enter. So how would I write my answer? 6.13 times 10 with an exponent of 7. And you have to write that as a little exponent up there. If you need help, raise your hand. Okay, go do this one. Huh? Can you wait till we're done with notes? Okay. Did everybody get the second one? Is 2.92 times 10 with an exponent of 10. Yes or no? Okay, let's do the next one. Now on this one, I personally, because I'm kind of old and my vision's not as great, I would go count the zeros. I would go like this. It's 0.1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. So 0 point and then 9 zeros. Because the biggest mistake I see students make is they get in a hurry and they just don't count the zeros correctly. And there's my answer. So how would I write this? 8.88 times 10 with an exponent of -10. All right, let's go do the next one. 0 point. Did we get 1.23 times 10 with an exponent of? Very good. So 1.23 times 10 with an exponent of -5. Let's do the next one. I got to go count these zeros. So I'm going to go like this. 3, 6, 9, 12, 15 zeros after that 4. I think I did it right. Did y'all get the same thing as me? Exponent of what? Okay. So I would write, and I have to write all that, 8.9044 times 10 with an exponent of 19. Okay, so on this one, again, I'm going to go count by marking them out. So I'm going to put 0 decimal, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 zeros. All right, what do y'all think? Easy? Now, how do you go from scientific back to standard? Number one, you can do it by hand, simply by moving the decimal place. So everybody look, go back up here. The exponent tells you how many times to move the what? The decimal. It does not tell you how many zeros to put. Do y'all hear me? What does the exponent tell you? How many times to move the? If it's positive, you go to the right. If it's negative, you go to the? So write that. Positive, go to the right. Negative, go to the left. Now, why is Miss Castro teaching me how to do this by hand? The calculator will not do all of these. It will do most of them. There will be a few you have to do by hand on this. Because the calculator says, hey, this is a crazy number. I'm not putting it in regular notation. I'm keeping it in scientific. Because the calculator thinks it makes more sense. And it does. But if your STAR test says make it normal, you have to make it normal. Make sense? All right, so look at this example right here. 6.3 times 10 with an exponent of negative 7. How many places will you move that decimal? 7. Which way will you move it? So I would take this and I would go like this. 1, 2, 3, 4, 5, 6, 7. It is going to add 6 zeros, not 7. And you can't ever know until you do it. So look, from here, 1, 2, 3, 4, 5, 6, 7. There's the decimal. Y'all see what they did? Okay, look at this one. What's the exponent? So you're going to move the decimal 5 places. If it's positive, you go. So I simply go like this. 1, 2, 3, 4, 5. It ended up adding how many zeros? 2. And there's your number. Now, will the calculator do some of them for you? Yes. For the calculator to do it, you simply go back to mode and get out of SCI and go back to what? Normal. So always try to let the calculator do it, and then if it doesn't work, then you can go do it yourself. So get your calculator, go back to mode, highlight normal, and hit enter. And then quit, second mode. Now let's go do these examples. So you're going to type these in and hit enter. If it goes to normal, then that's your answer. If it keeps it in scientific, you have to do it by hand. Make sense? All right, let's try the first one. So everybody type in 4.52 times 10. How do I get to the exponent? Everybody look. The little caret button. Y'all see it? Hit caret, it pushes you up to the exponent. Put your exponent in, hit enter. Did this one go from scientific back to normal? So all I have to do is write my answer. So my answer is 452 with 1, 2, 3, 4 zeros. If you like putting commas, you can. I'm not going to make you. But technically this would look like that. Okay? Try this one, and notice it might not work. So let's try it. $6.78 times 10, carry it up, and make sure you're hitting negative. Everybody remembers negative is below the 3. Yes? Negative 14. Hit enter. Did this go from scientific back to normal, or did it keep it scientific? Why? Your calculator said, I don't want to put it back to normal. That's too much. So you have to do it by hand. So let's talk about it. Circle the exponent. What does that tell you? How many times to move the? But how many times to move the? Decimal. Since it's negative, I go to the. So here's what you do. Rewrite that number right here, real small. 6.78. Now, you're going to have to write legibly so you can see what you're doing. You're going to draw 14 places to the left. Watch what I do. That's 1. You'll see what I'm doing? Here we go. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Here will be my new decimal. What will go in those little baskets? Do not put the baby on the side of the basket. The baby has to go in the basket. Do y'all understand? Now, that's not a pretty answer. That's just me showing my work. I'm going to write my answer below that. It's going to be a decimal with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 zeros. And then 6, 7, 8. Notice I did not write the decimal between the 6 and the 8 because it moved. If you put a decimal here and a decimal here, it's wrong. You moved it. All right, try the next one. Did this one work? Nope, so we got to do it by hand. So I write 1.03 and I move the decimal how many places? 7. Which direction? Left. So here we go. 1, 2, 3, 4, 5, 6, 7. Here's my new decimal. And little zeros go in the baskets. So my answer is decimal and then 1, 2, 3, 4, 5, 6 zeros. 1, 0, 3. Are y'all catching on? Okay, question. Could I put a 0 in the ones place value? Yes. Okay. All right. Let's do the next one. Let's see if this one will work. No. So I said a lot of these won't work. And some of y'all's calculators might do it and mine won't. Like, it just depends. Okay, so let's go do it by hand. I write 3.347. Notice I wrote it this way because this time the exponent is what? So I'm going to be going this way to the right 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I ended up adding 7 zeros. Again, you don't have to have commas in your answer, okay, but you do have to have decimals if it changes the value. All right, let's try this one. This will be our last one. Hopefully the calculator is going to do this one. So 7.67 times 10 with an exponent of -4. It didn't do it. All right, so we got to do it by hand. So I write 7.67. Which way am I moving the decimal? To the left 4 times. 1, 2, 3, 4. Here's my new decimal. And little zeros go in the baskets. So decimal with 3 zeros. 7, 6, 7.